Comparison between boron and aluminium. 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 Similarities. Boron and aluminium both contain 3 electrons in the outermost orbits and are trivalent. Boron and aluminium both contains 3 electrons. Both contains 3 electrons in the outermost orbits. And are trivalent. Okay. Second point. This is first point and second point. Both forms M2O3 type of oxide. Both forms M2O3 type of oxide. Type of oxide is that B2O3 and Al2O3. Okay. Third point. Both boron and aluminium combine with nitrogen to form nitrides which undergo hydrolysis and liberate ammonia. Okay. Both boron and aluminium combine with nitrogen. Both boron and aluminium combine with nitrogen to form nitrides which undergo hydrolysis and liberate ammonia Okay. Then boron nitride plus 3H2O, that is H3BO3 plus liberate ammonia, and aluminum nitrate plus water, that is aluminum hydroxide AlOH whole thrice plus ammonia, liberated ammonia. Okay. And fourth point. Point 4. Boron and aluminium react with alkalis to form borates and aluminates. Okay. Boron and aluminium react with alkalis. Boron and aluminium react with alkali to form borate and aluminate. Borates and aluminates. Borates and aluminates. Okay. then 2B plus 6NaOH, 2B plus 6NaOH, that is 2Na3BO3 plus 3H2 plus 3H2, and 2 aluminium plus 2NaOH plus 2H2O, that is 2NaAlO2 plus 3H2. Okay, 3H2. Fifth point, fifth similarities. Boron and aluminium form covalent chlorides which are prepared by similar method. Boron and aluminium form covalent chlorides which are prepared by similar method, which is prepared by similar method. B2O3 plus 3C plus 3Cl2, that is 2BCl3 plus 3CO, and Al2O3 plus 3C plus 3Cl2, that is 2AlCl3 plus 3CO. Okay, these chlorides are volatile and are readily hydrolyzed. These chlorides are volatile and are readily hydrolyzed. Okay, then BCl3 plus 3H2O, that is H3BO3 plus 3HCl. Okay, and AlCl3 plus 3H2O, that is AlOH whole thrice plus 3HCl. Okay, 3HCl. 6 points. Both boron and aluminium forms covalent compound with valency 3 like BCl3, BH3, BF3 and AlCl3. Okay, both boron and aluminium forms covalent compounds. With valency 3 like BCl3, BH3, BF3 and AlCl3. 7th point. Both boron and aluminium forms organic compounds with alkyl radicals. Both boron and aluminium forms similar organic compounds with alkyl radicals. Okay, example 2BCl3 plus 3 ZnCH3 whole twice, arrow mark of 2BCH3 whole thrice plus 3 ZnCl2. Okay, and 2Al plus 3Hg CH2 whole twice, that is 2Al CH3 whole thrice plus 3Hg. Okay, 3Hg. Okay, next heading dissimilarities. Next, dissimilarities. Okay, next dissimilarities. Okay, what is dissimilarities between aluminium and boron and aluminium? Okay, dissimilarities. Dissimilarities between boron and aluminium. Okay, dissimilarities between boron and aluminium. Boron is a typical non-metal, whereas aluminium is a metal. Boron is a typical non-metal. Boron is typical non-metal, whereas aluminium is metal. Second point. Boron is a bad conductor of hot and electricity, while aluminium is a very good conductor. Boron is bad conductor of hot. Boron is bad conductor. Boron is bad conductor of hot. Boron is bad conductor of hot and electricity. Boron is a bad conductor of hot and electricity. Boron is bad conductor of hot and electricity, while aluminium is very good conductor. Very good conductor. Third point. Dilute acids have no action on boron, but aluminium is attacked by dilute acid. Okay? Dilute acid have no action on boron. No action of boron. Dilute acid have no action of boron. Okay? Action of boron. But aluminium is attacked by dilute water or dilute acids. Fourth point. Boron forms a large number of covalent compounds, while aluminium forms only a few covalent compounds in the anhydrous states. Boron forms large number of covalents. Boron forms large number of covalent compounds, while aluminium forms only a few covalent compounds. In the anhydrous state. In the anhydrous state. Fifth point. Stable salts of boron forms large number of covalent compounds, while aluminium forms only a few covalent compounds in anhydrous state. Stable salt of boron are borates, but aluminium not stable. Stable salts of boron are borates, but aluminates, but aluminates are not stable. Are not stable. Not stable. Stable salts of boron are borates, but aluminates are not stable. Aluminates are not stable. 6 point. 6 point. Sulfates, nitrates, chlorides of aluminium are its stable salt, while boron does not form such salts. Okay? Sulfates, nitrates, chlorides, etc. of aluminium are is stable. Are its stable salt. Its stable salts, while boron does not form such salts. Okay? Sulfates, nitrates, chlorides of aluminium are its stable salts, while boron does not form such salts. Okay? 7 point. Boron has no action with water or steam, but aluminium decomposed by steam and leave hydrogen. Okay? Boron has no action with water. Boron has no action with water. Boron has no action with water or steam, but aluminium decomposed by steam and liberate hydrogen gas. Two aluminium plus 6H2O, that is 2AlOH whole price plus 3H2O. Next point, point 8. B2O3 is acidic, while Al2O3 is emphatic. 9 point. Boron forms several volatile hydrates. Boron forms several volatile hydrides. Example B2H6, B4H10, etc. Whereas aluminium forms non-volatile hydrides. Non-volatile hydrides. Okay? AlH3. 10 point. Point 10. Point number 10. Boron does not form alum, but aluminium forms alum. Okay? Boron does not form forms alum. Boron does not forms alum. Boron does not forms alum, but aluminium forms alum. But aluminium forms alum. Aluminium forms alum. Okay, alum. 11 point. Crystalline. Boron is hard. While aluminium is soft. Aluminium is soft. 12 point. Boron exhibits allotropy. That means amorphous and crystalline. Allotropy means amorphous and crystalline. Amorphous and crystalline. Aluminium does not. Okay? Does not. 13 point. 13 points. Okay, next 13 points. Next 13 points. Okay, 13 points. Point number 13. X. Then BCl3 is monomeric. BCl3 is monomeric. BCl3 is monomeric. AlCl3 is dimeric. Okay, as Al2Cl6. Okay, 14 point. With nitric acid, boron forms H3BO3. Boron plus 3HNO3. Nitric acid, that is H3BO3 plus 3NO2. Okay, and nitric acid has no action. Nitric acid has no action on aluminium. Okay, aluminium. The metal is rendered passive dye to surface oxidation. 15 point. H3BO3 is weak acid. H3BO3 is a weak acid. Whereas aluminium AlOH whole thrice is amphoteric in nature. Okay, next anomalous behavior of boron. Okay, next anomalous behavior of boron. Anomalous behavior of boron. Okay, anomalous behavior of boron. Okay, the first element boron of group 13 differs the rest element due to the first element boron of group 13. The first element boron of group 13 differs the rest elements, elements due to its first point, small size, small size, second point, high electronegativity value, high high electronegativity, and third point, options of d orbitals, options of d orbitals, okay. The first element, boron of group 13, differs the rest elements due to its small size, high electronegativity value, and absence of d orbitals. Property of boron differs from the other elements of group 13. It differs from the other members in the following ways. Properties of boron differs from the other elements of group 13. Properties of boron differ. Properties of boron differ from the other elements. Of group 13. It differs from the other members in following ways. Okay. Other member in following ways. Okay. First point. Boron is a non-metal and other are metals. Boron is non-metals. Boron is non-metals and other are metal. Okay. Second point. Boron exhibits allotropy. Boron exhibits allotropy. Boron exhibits allotropy, amorphous and crystalline. Amorphous and crystalline. Okay. Amorphous and crystalline, while other does not. Okay. Third point. Okay. Oxides and hydroxides of boron are acidic in nature. Oxides and hydroxides of boron are acidic in nature. Acidic in nature. Oxides of aluminium and gallium are amphoteric. While oxides and hydroxides of indium and thallium are basic. Okay. Oxides and hydroxides of boron are acidic in nature. Oxides of aluminium and gallium are amphoteric, while oxides and hydroxides of indium and thallium are basic. Fourth point. Point 4. Fourth point. Boron does not form hexagon complex. Boron does not form hexagon complex. Whereas others forms complex ions such as MH2O whole 6 and power plus 3. Okay, plus 3. Okay, fifth point. Okay, next point. Point 5th. Anomalous behavior of boron point 5th. Fifth point. What is fifth point? Dilute acids have no action on boron. Dilute acids have no action on boron, but aluminium is attacked by dilute acids. Attacked by dilute acids. Okay, as an example, 2Al plus 6HCl, that is 2AlCl3 plus 3H2. Okay, gallium, indium and thallium are also dissolved by acid. Dilute acid have no action on boron, but aluminium is attacked by dilute acid. Gallium, indium and thallium are also dissolved by acids. Gallium and indium form trivalent ions. But thallium yields a univalent ion. Univalent ion. Sixth point. Melting point of boron. Boron to 20-30 degrees Celsius is higher in comparison to rest of other elements. Okay. Gallium, indium, thallium are also dissolved by acid. Gallium and indium form trivalent ions. But thallium is univalent ions. Sixth point. Melting point of boron 20-30 degrees Celsius is higher in comparison to rest of other elements. Okay, and seventh point, boron forms several volatile hydrides. Boron forms several melting point 20 degrees is higher in comparison to rest of other elements, and boron forms volatile several volatile hydrides several volatile hydrides. Example: B2H6, B4H10, and gallium form a volatile Ga2H6. Aluminium or non-volatile aluminium or non-volatile aluminium or non-volatile AlH3 while in forms of salt like hydrides while in forms or salt like hydrides okay. 8 number 8. 8 point, but 7 point you know also about boron. Boron forms several volatile hydrides, so B2S6, B10H, B4S10, and gallium forms a volatile Ga2S6. Aluminium or non-volatile AlH3 while in forms of salt like hydride. 8 point, boron combines with metals to form borides, whereas others do not form borides. Okay, boron combines with metals. Boron combines with metals. Combine with metals to form borides. Whereas other do not form borides. Okay. 9 point. Boron does not form alum, but boron does not form alum, but aluminium, gallium, and indium form alums. 10 point. Boron generally forms covalent compounds with the other elements of group 13 forms both covalent and electrovalent compounds. Boron generally forms covalent compounds. Boron generally forms covalent compounds. Boron generally forms covalent compounds, whereas other elements of the group 13 form both covalent and electrovalence, electrovalent compounds, okay. Boron generally forms covalent compounds, whereas other elements of the group 13 forms both covalent and electrovalent compounds, okay. 11 point. Boron does not form, boron does not form, boron does not form B plus 3 ion, but other elements of a group form M plus 3 ions. This is because the second and third ionization energies of boron are very high. Okay. Boron does not form boron plus 3 ions, but other elements of this group will form N plus 3 ions. This is because the second and third ionization energy of boron is very high. Okay. Next, diagonal relationship between boron and silicon. Diagonal relationship between boron and silicon. Diagonal relationship between boron and silicon. Okay. Boron and silicon show resemblance in properties. Okay. The resemblance arise due to the fact that boron and silicon are non-metals and have a smaller difference in size. The following properties illustrated similarities in the boron and silicon. Okay. First point. Okay. Boron and silicon show resemblance in properties. Okay. Boron and silicon show resemblance in property. The resemblance arises due to the fact that both boron and silicon are non-metals and have a small difference in size. The following properties illustrated similarity in boron and silicon. First point. This is lithium, beryllium, boron, carbon, sodium, magnesium, aluminium, silicon, boron, silicon, beryllium, aluminium, lithium, magnesium. Okay. Boron and silicon are diagonally related. Boron and silicon are diagonally related. Both are typical non-metals. Both are typical non-metals. Non-conductors, unable to form cations, and possesses high melting points, both show allotropy, both show allotropy, okay? Boron and silicon are diagonally related. Both are typical non-metals, non-conductors, unable to form cations and possesses high melting points. Both show allotropy. Second point, both are immune to dilute acids. Both are immune to dilute acids. Third point, both B2O3 and SiO2 both are immune to dilute acids. Both B2O3 and SiO2 are acidic and insoluble in acids, but dissolve in alkalis, okay? Then B2O3 plus 6NaOH, that is 2Na3BO3 plus 3H2O. Okay? Both B2O3 and SiO2 are acidic and insoluble in acid but dissolve in alkalis. Insoluble in acids but dissolve in alkalis. And SiO2 silicon dioxide plus sodium hydroxide NaOH, okay, equal to Na2SiO3 plus H2O, okay. Fourth point, both form covalent hydrides. Both form covalent hydrides. Boroethane B2H6, silicoethane Si2H6, borobutane B4H10, and silicobutane Si4H10, okay. Both form covalent hydrides. Boroethane B2H6, silicoethane Si2H6, and borobutane B4H10 and silicobutane Si4H10. Fifth point. Boron and silicon combine with metals to form borides and silicides respectively. Okay? Boron and silicon combine with metals to form borides and silicides respectively Mg3B2 and Mg2 silicon, okay. 6 point. Both forms covalent. Both forms covalent chlorides which are hydrolyzed in aqueous solution. BCl3 plus 3H2O, that is H3BO3 plus 3HCl, and the next SiCl4 plus 3H2O, that is H2SiO3 plus 4HCl. Okay. BCl3 and silicon chloride SiCl4 are covalent and monomeric. BCl3 and SiCl4 are covalent and monomeric. Covalent and monomeric. Okay. Boron has empty p orbitals and silicon has empty d orbitals. Boron has empty p orbitals and silicon has empty d orbitals. Okay. 7 point. Point 7. Boron and silicon dissolve in alkalis to form borates and silicates and liberate hydrogen gas 2b plus 6NaOH, that is 2Na3BO3 plus 3H2. Next, silicon plus sodium hydroxide NaOH plus water H2O, that is Na2SiO3 plus 2H2. Okay. 8 point. Point 8. Point 8. 8 point. Point 8. 8 point. 8 point. Boron and silicon are not attacked by water at any condition, hence B3 aqueous and Si4 aqueous do not exist. Okay. Both boron and silicon can be obtained by the reduction of their respective oxide with magnesium. Both boron and silicon can be obtained by the reduction of their respective oxides with magnesium. Okay. 10 point. H3BO3 and H4SiO4 are very weak acid. Very weak acid. 10 point. 11 point. B2S6 and SiH4 are prepared from borides and silicides by the reaction of dilute acids. Mg3B2 plus 6HCl, that is 3MgCl2 plus B2S6, and Mg2Si plus 4HCl, that is 2MgCl2 plus SiH4. Okay. Diagonal relationship between boron and silicon. Boron and silicon show resemblance in property. The resemblances arises due to the fact that both boron and silicon are non-metals and have a small difference in size. The following properties illustrate similarity in boron and silicon. First point. Boron and silicon are diagonally related. Both are typical non-metals, non-conductors unable to form cations and possesses high melting point. Both show allotropy. Both are immune in dilute acid. Both B2O3 and SiO2 are acidic and insoluble in acid but dissolve in alkalis. Okay. Both are covalent hydrides. Both ethane B2S6 and ethane Si2S6, borobutane B4S10 and silicobutane Si4S10. Boron and silicon combine with metal to form borides and silicides respectively Mg3B2 and Mg2Si. Both form covalent chlorides which are hydrolyzed in aqueous solution. And BCl3, boron chloride and silicon chloride are covalent. Silicon boron trichloride and silicon tetrachloride. Boron trichloride and silicon tetrachloride are covalent and monomeric. Boron has empty p orbitals and silicon has empty d orbitals. Boron and silicon dissolve in alkalis to form borates and silicates and liberate H2 hydrogen gas. 2b plus 6 NaOH Na2BO3 plus 3H2. Silicon plus 2 NaOH plus H2O Na2Si3 plus 2H2. Boron and silicon are non-attacked by water at any condition, hence boron plus 3 aqueous and silicon plus 4 aqueous do not exist. Both boron and silicon can be obtained by the reduction of their respectively oxide with magnesium. H3BO3 and H4SiO4 are very weak acids. B2S6 and SiH4 are prepared from borides and silicides by the reaction of dilute acids. Okay. Hence comparison between boron and carbon. Comparison between boron and carbon. Next point. Comparison between boron and carbon.